In this lesson, we're going to focus on how to solve equations algebraically using the inverse method. And some of you may remember this from last year. This is called either one-step or two-step equations. And we're pretty much doing exactly that. But this time, instead of calling it one-step and two-step equations, we're just going to call it solving equations. And it's important to know what inverse operations are. So another word for inverse is opposite, and our four main operations are plus, minus, multiplication, and division. The opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplication is division, and the opposite of division is multiplication. And you'll see why these are important in our examples from this video. So why are inverse operations important? They're important because we use them to obtain the value of the pronumeral when we are solving an equation. So for example, x plus 2 equals 16. What we're going to do and what we're going to learn to do is to practice using these arrows here. So we want to get x by itself. Okay, so we're going to say to get x by itself, we have to subtract 2. But because it's an equation, we have to do it to the same side. So that means if I do x plus 2 minus 2, I'm just going to end up with x. And if I do this, I'm going to end up having 16 take away 2, which gives me 14. Let's do another one. b take away 10 equals 5. So we want to get rid of this take away 10 by adding 10. So I'm going to add 10 to this side, and I'm going to add 10 to this side. The most important rule about doing this is that whatever you do to one side, you must do to the other. So if I add 10 to this side, this 10 is going to disappear, and I'm going to be left with b. 5 plus 10 is 15. What happens if we have multiplication? Well, here we know in algebra that 2t is 2 times t, so we want to do the opposite, which is divide by 2. Divide by 2. And just like we have done in the past, if we have 2t over 2, well, these two 2's cancel out and we're left with t. So that's how we get t here by itself. And 16 divided by 2 is 8. Last one, we have division. And the opposite of division is multiplication. So if I was to get rid of this 3, because I want r to be by itself, I am going to multiply both sides by 3. And again, r over 3, if I multiply this by 3, it's the same thing as having the 3 up here, and these 3's cancel out, which gives me r by itself. So that will leave me with r on this side, and 6 times 3 is 18. Now the beauty about solving algebraically is that you can check if you're right or not. So I might do it in yellow. My x is 14 here, so 14 plus 2, does that give me 16? Yep, that's correct. My b is 15. 15 take away 10, does that equal 5? Yep, that's correct. T equals 8, so 2 times 8, does that equal 16? Correct. R equals 18, so 18 over 3, does that equal 6? Correct. And that's what you should be doing, so that way you know for sure that you're right, even before you check the answers. So here you'll notice that we have multiplication and subtraction. So if we want to do the opposite of these, which one do we do first? And this is probably the hardest part about solving equations algebraically, knowing which ones you need to remove first. So this is what we would have done last year, which is called two-step equations. Now, the best way to do this is to think about, okay, how did we come up with this equation? Well, obviously, 3x take away 10. Did we do x take away 10 and then did we multiply it by 3? Or did we do 3 times x, and then we subtracted 10. That seems to make a bit more sense. Okay, so if we were to have it the other way around, then we'd have a different equation. We would have x take away 10 multiplied by 3, and that is a completely different equation altogether. So the order does matter. So if you don't see brackets, you're going to assume that 3 times x was done first. And the reason why this is important is because just like when you're putting on your socks, then you're putting on your shoes, okay, you don't take off your socks before you take off your shoes. You do everything in reverse order. So because we did the multiplication first, I'll write that here. And then we did subtraction second. Well, then we need to cancel this out first and cancel this out second. Thinking always about that example with putting on your socks, then putting on your shoes, then taking off your socks, then taking off your shoes. So with that in mind, our first step is going to be adding 10 to both sides. Okay, and that will get rid of this 10 here, give us 3x, and this will give us 15, because 10 plus 5 is 15. Now we can worry about getting rid of the multiplication. So that means the opposite of multiplication is division. So I'm going to divide both sides by 3. And that's going to give me x on its own and 5. So let's just backtrack a little bit. We realized that the equation was made up of first multiplication and then subtraction. So what we did was we cancelled out the subtraction by adding, and then we cancelled out the multiplication by dividing. Now let's have a look at this next example. So it's sort of the similar example, except it looks a little bit different. We can see here that we have a negative 10 and then a plus 7. So what happens if I did negative 10 plus 7, all of that multiplied by z? No, that doesn't seem right. It seems like what we've done here is we've multiplied 7 with z, and then we've taken 10 away. Now that here is the exact same thing as this, except it's just written in a different order. So what I'm going to do here is I'm just going to rewrite this with minus 10 plus 7z, and that's exactly what we've got here. So don't get confused with the order that it's written in. You still know that you have multiplication and subtraction, and it's just a matter of which one you're going to get rid of first. So this is the same thing as the previous example, okay, which means now we need to get rid of subtraction first. And how do we do that? We do that by adding to both sides. So I'm going to add 10, and this is going to give me 7z equals 21. And to cancel out multiplication, we are going to divide. And to do that, we're going to divide both sides by 7. 7z divided by 7 is just z, and 21 divided by 7 is 3. Now, it looks like we're all finished, but what I'm going to do is I'm going to check my answers for both of them. If x equals 5, 3 times 5 minus 10 should equal 5. So this is 15. Take away 10. Yep, that equals 5. So correct. How about this one here? Minus 10 plus 7. Well, we just found out that z equals 3. Okay, so doing BODMAS, This is 21 minus 10 plus 21, okay, should give me 11. And that is correct. Now, there's a lot of work there, but once you do this a few times, this will become a bit of a routine and a bit of a habit, and you'll soon realize just how easy this is.